All right, so today is Unit 4, Day 8A, and we're going to be solving some trigs. So some of these are applications. Some of these problems you probably remember from geometry. So some of them are pretty simple, and you won't have to think too much about. Some of them you have to think a little harder about, and you didn't see in geometry, and they're kind of applying it and taking it a step further. So I can apply the concepts of trig to solve real-world problems. And so we need to revisit the angles of elevation and depression. So remember, if you're looking straight out and the thing, or I should say if you're looking down at something, the angle from straight out to where you're looking is the angle of depression. Your depression means going down, and then elevation would be if you're looking up at something. So if this is a person on the ground, or if this is a building and you're looking up at a plane, that's the angle of elevation. Whereas if you're on the plane and you're looking down at the house, or the person, then it's the angle of depression going down. These lines being parallel, these are going to be alternate interior angles, so they'll be equal. So it's kind of nice that you can actually screw it up without screwing up your answer. If you accidentally don't recognize that it's actually an angle of elevation versus depression, you might still get it right, even mess it up. But try to get it right. Try to label it correctly. So here, Brian's kite is flying above a field at the end of a 65-meter string. If the angle of elevation to the kite measures 70 degrees, how high is the kite above his head? So you think here's Brian, and he's looking up at the kite. Up here's the kite. So this would be straightforward. So the angle of elevation here is 70 degrees. They tell us that this is a 65-meter string. And we're trying to find how high above his head it is, so we're trying to find that x right there. So just think back from geometry. This is, you want the side opposite. The hypotenuse, that's sine. So sine of 70 equals opposite over hypotenuse. You probably remember a fast way to put in this calculator is solve for x first and then type in the calculator. So on this I'd multiply 65 to both sides. So you type in your calculator 65 sine of 70. Make sure, since we're doing angle or degrees here, most applications, almost all applications are degrees. So make sure your calculator is in degree mode, and then type this in the calculator. You get x equals 61.08 meters. From a point on the ground, 12 feet from the base of a flagpole, the angle of elevation to the top of the pole measures 53 degrees. So you got this flagpole here. We want to know how tall that is. Really getting fancy here with my artwork. And then a point on the ground 12 feet from the base, so 12 feet over, has a angle of elevation to the top of 53 degrees. So looking at this right triangle, and again, assuming that the flag was put in the ground perpendicular to the ground, whoever installed it, hopefully they knew what they were doing, it's perpendicular. Then I want the side opposite, I know the side adjacent, so that's tangent. So tangent of 53 equals opposite over adjacent. Again, multiply the 12 over, type this in your calculator, and you get 15.92 is how tall the flagpole is. So 15.92. Let's see. Now again, a little bit crazier. So those are probably questions you saw in geometry. These may not have been, and that's okay. So let's just figure it out. So from a plane flying due east at 265 meters above sea level, the angles of depression of two ships sailing due east, so they're going the same direction, they're going east, measures 35 and 25. How far apart are the ships? So try to find how far apart those two ships are. So first you got this plane up here, and I'm not going to even try to draw a plane. But it's above some water. So here's some water. I can draw water. and it says that so it's going due east. It is 265 meters above. The angle of depression to two ships, to one of them it's 35 degrees, and one of them it's 25. So you think, I'm going to look down 25 degrees to the further one over here somewhere. So that's 25 degrees. Then we're going to look a little bit further down, 35 degrees to another one. So this is 25, this is 35 degrees. Okay, so a real good way of doing this is I want to find this distance right here. So I'll just call that D for distance. And I'm going to need to mark this right here. So maybe I'll mark these like that. So I'm just going to call this X. But in the end, I want to find distance. The distance between the ships is what I'm really trying to find here. So kind of look at it as two separate triangles. Now, going this way, if this is again, we assume you're looking straight out, that's parallel to the water. So if this is 35, then that means this angle is 35. If this is 25, that means this angle is 25 here. So look at it as two separate triangles. Let's do this triangle first. If I could find X, I could eventually find the total length and then subtract it. So like X plus D and then subtract X from it. So I could say that tangent of 35, so opposite over adjacent, so it'd be 265 over X. You can solve for X. So X equals 265 divided by tangent 35. Now the other one, if I do 25, so tangent of 25 is going to equal opposite 265 over X plus D, both of them together, because that would be, think of it as one big triangle here. And X plus D would equal 265 divided by tan 25. Since I'm trying to get D, I'm going to solve or subtract the X over. So now the distance is going to equal 265 divided by tangent 25 minus whatever X is. Well, here's what X is. So the distance is going to equal 265 over tangent 25 minus 265 over tangent 35. Now you're probably saying, like, I would just find X by itself, get a number, find this answer, and subtract X from it, and that's fine. We're just kind of showing you, like when you get to calculus, you would want to set it up and leave it all like this, because you may be doing something with it. It might be saying, how are the distance of the ships changing, or how is the distance from the plane to the ship. But we're going to ask more difficult questions, and you want to leave it in terms of the functions and tangent like this, and then because then you can do more work with it. So try to introduce it in your head of leaving things in terms of their functions until the very last step. So now once you type that in the calculator then, so for pre-calc, we just type these in the calculator, and the distance is 189.84. This was meters. Okay. Tom and Sam are on opposite sides of a tower. So there's this tower that's 160 meters tall. They measure the angles of elevation to the top of the tower. So one side is 40, one side is 55. So let's see here. So we'll say 40. We'll do this one first. So that's 40 degrees. So maybe that's Tom or Sam. I don't know which one it is. We'll say Tom's here. And then Sam's a little bit further away. We'll say 55. Actually be closer. I guess I'm not drawing that to proportion because the smaller the angle, the further away you are. But anyway, so we're not really thinking drawing proportion here, but we'll leave it alone because I don't want to redraw that. But we're just saying find the distance between Tom and Sam. So I know Tom or Sam is here and the other one's there. I'm trying to find this entire distance. So I'll just call one X and I'll call one Y. So we'll just, and then my answer I'm trying to find is X plus Y. I don't know what X plus Y is. So here, looking at this left triangle, opposite over adjacent is tangent. So tangent 40 equals 160 over X. And then on the other side, opposite over adjacent, so tangent 55 equals 160 over Y. Okay, solve for X and solve for Y. So X would be 160 over tan 40. Y would equal 160 over tan 55. So X plus Y would equal 160 over tan 40 plus 160 over tan 55. Type those in the calculator. It's 302.71 meters. Okay, again, we want to leave it in terms of the functions, the tangent functions, because when you get to calculus, these people might be walking. They might be walking towards or away from that the pole and you're trying to figure out how is that distance changing, what's their speed or something like that. So just planting that idea of leaving it in terms of the function. Now let's flip this over. Going to the back side, we're going to talk about bearing again. So we can do some trig and bearing measurements. So to specify true bearings, first we got to consider the following. So the angle is measured from due north, and the angle is measured in a clockwise direction to the bearing line. The angle of rotation may take any value from 0 to 360, so we're looking at straight up north, and we open this way. The symbol T is used to indicate that it's a true bearing, and then you notice in here I forgot to do that. So like down here, I forgot to put a T there to show that it's a true bearing. But anyway, so for example, 125T, 270T, and so on. For bearings less than, that should be a capital F, for bearings less than 100, we use 3 digits. So instead of saying 45 degrees with a capital T, we say 045 or 078, just so 3 digits. We try to always keep it 3 digits as we're writing it. When you're drawing it, be careful. It depends what you're talking about from what to what. So if I was talking about, if A is here and B is here, and the same orientation over here, kind of ignore that Cartesian plane there. So if A and B are oriented, so maybe this is a ship and a lighthouse, and that's a ship and a lighthouse. So A is the same thing. If the bearing is from A to B, then you're going to open up this far, which is a little more than 90, a little less than 180 degrees. But if you're going from B to A, well, the bearing is going to be between 270 and 360 because you're looking that way. So what direction you're looking from and to make a big difference. So an airplane flies on a course of 110 degrees true bearing at a speed of 1,200 kilometers per hour. How far east of its starting point is it 2 hours later? So I think here's an airplane starting right here, and so it's going a bearing of 110 degrees. So it's going to go, let's see, so 110 would be about 20 degrees more than 90. It's going to be going this way. So this is north, this is east, this is south. So it's actually going southeast. And they want to know how far east did it go. Well, if it was going 1,200 kilometers per hour for 2 hours, that'd be 2,400 kilometers it traveled. But I want to know how far east did it go. So I'm just trying to find this component of it. I almost think about vectors. I don't know how much work you've done with vectors, but think of this as like a vector notation, which we're going to get into eventually. But so if this is 110, that means this is 20 degrees inside of here. So I got to convert that before I type it in the calculator. Okay. So this I want the adjacent. I know the hypotenuse. That's cosine. So cosine 20 equals adjacent over hypotenuse. Solve for x, so 2,400 cosine 20. Make sure you're in degree mode, so that equals x. So x is going to be 2255.26 kilometers. Okay, a plane is 160 miles north and 50 miles east of an airport. The pilot wants to fly directly to the airport. And so what bearing should it take? So this is kind of backwards thinking because you've got a plane and you've got, which is north and east. So north and east of the airport. The airport's over here somewhere. So to get there, you're going to have to travel south and west, or west and south, however you want to say it. So this is going to be true north here, and I'm going to have to travel this way to get there. Okay, so how many degrees around is that? So I know for sure it's going to be 180 plus some more, or you can think of, well, we'll do it this way. So I'll do x here like this. I could figure out this angle here. I would have to subtract from 270 versus add to 180. So there's two ways of doing this. Kind of two ways of killing two birds with one stone, I guess. So it is north 160, it's east 85, and I'm trying to find, first off, this angle in here, and then find out what the bearing would be. So opposite adjacent, so tan x equals 85 over 160. Again, this is where you have to do inverse tangent. So the angle for this would be 27.98 degrees. That's this angle right here. I need to do from due north, so I have to add 180 to that. So this would be 207.98. You could probably just say 208, 280 degrees from true north. A ship is 70 miles east and 40 miles south of a port. The captain wants to sail directly to the port. So what bearing should we take? And kind of the exact same question here. So you've got the ship here, and it's east and south of the port. So we're starting right here. Here's north. I want to get to there. So off the bat, I know this is going to be a little more than 270. I just need to find out what this angle is right here. So the ship is 70 miles east and 40 miles south of it. So if I can find that angle in there and then add 270 to it, I got my answer. So I've got opposite adjacent, so tan of theta would equal 40 over 70. Type in the calculator, I get 60.255. Now that's the angle right there. I got to add 270 to it. Whoops. So add 270 to it, and I get 330.255 from true north. Whoops. Let me put that on the screen. Now the last one here, I got the picture there for you because it was kind of confusing, but the picture is pretty helpful for seeing what's going on. So a boat leaves Port Cleveland, which is this point right here. So we'll say Port Cleveland. And it averages 25 knots per mile. So that's just the average speed. Traveling for 2 hours on a course 53 degrees from true north. So going this way. And then it stops. And it goes 3 hours in this direction, which is just 143 now. Like that. So it's 143 going this way. They want to know what's the boat's bearing. So now when it gets there, what's its bearing from where it started, and what's its distance from where it started. So kind of two routes you want to take here. One of them is, first off, this went, if it's 35, which is nautical miles per hour for 2 hours, that's 70 knots. If it went 3 this way, that'd be 105. So if I want to find the distance, first off, just do Pythagorean theorem with this. So 70 squared plus 105 squared and square root. So I'll just put AC is going to equal 126.19 knots. So that's the distance. Now the bearing on this, I want to find that angle first off. Now once I find that angle, I have to add 53 to it because it's from true north. So if I want to find this angle, a couple different routes you can take. I just did tangent. So tangent of that angle is opposite over adjacent. So 105 over 70. That means theta, when I put in the calculator, is 56.3. So that's this angle here, but I need from true north, so I need to add 53 to it. So this would be 109.3 from true north. So just some problem solving skills here with some trig stuff that hopefully you guys remember from geometry, and maybe applying it in a little bit more difficult problems. But yeah, let me know if you have any questions.